Okay, so at this point you know how to use the elimination method to solve a system of linear equations. But what happens when you're given two equations that you can't easily add or subtract them to eliminate one of the variables? So let's look at an example of this. So what if you were given 2x plus 3y equals negative 2 and 3x plus 6y equals 3. In all the examples you've seen so far, there's something like maybe 2x and another 2x, or 2x and a negative 2x, or something like that. These ones don't have any that are easily eliminated. So what you need to do is multiply one or both of the equations by a constant number. So you would end up multiplying every term in that equation by this number, so that you end up with two equations where you can add or subtract them to eliminate the variables. So I'm going to show you what I mean by this. So if we look at this, we have a 2x and we have a 3x. We also have a 3y and a 6y. So the easiest thing that I'm seeing here is if we multiply this entire first equation by 2, we'll end up with a 6y over here to match this 6y, so then we can easily eliminate. So I'm going to rewrite these equations a little bit smaller. And then we'll go from there. Okay, let's try this again. Alright, so we had 2x, actually let me put them over the side here. 2x plus 3y equals negative 2, and 3x plus 6y equal to 3. So I'm going to take this entire first equation and multiply the entire thing by 2. So every single term here will be multiplied by 2. So 2 times 2x will give me 4x. 2 times 3y will give me 6y. And 2 times negative 2 will give me negative 4. So this is my new first equation here. It's equivalent to the other one because if we divide 2 out of every term, we'll end up with the first one again. Okay, so we have that equation. The second equation, I'm just going to write the way it is below the first one. So we have 3x plus 6y equals 3. Now we have a 6y and a 6y. So I can see that if I subtract the entire second equation from the first one, just like in the other video from Khan Academy, we'll end up eliminating the y's and we'll just be left with an x, so we can solve for x. So I'm going to take the first equation, subtract the second equation. So 4x minus 3x will just give me x. 6y minus 6y will give me 0y, so I'm not going to write that down. And negative 4 minus 3 will give me negative 7. Well, this was a fairly simple example because we already have solved for x. And just like in the substitution method from before, we substitute x equals negative 7 into one of the equations. At this point, you can pick any equation. You can use this one, this one, this one, or this one. The two original equations are going to be the easiest. So let's say we'll plug it into this one. So we'll have 3 times negative 7 plus 6y is equal to 3. So we'll have negative 21 plus 6y equals 3. Add 21 to both sides, we'll end up with 6y equals 24. Divide both sides by 6, and we'll have y, that should be a y, equals 4. It's kind of hard to read, I apologize. But basically what we have here is negative 7, comma 4. There's our ordered pair. That is our solution to this original system of linear equations up here. I'm going to show you another example. This time we're actually going to have to multiply both of the equations by different numbers so that we end up with equations where we can use elimination. So we have our first equation is 5x plus 4y equals 38. And our second equation is 2x plus 3y equals 25. Just like before, we don't have anything that we can easily add or subtract the second equation from the first. We're going to multiply these by some numbers so that we can eliminate them. So there's multiple options here. One option is to multiply the first equation by 2 and the second equation by 5. So basically, I'm going to end up with 10x in both of them. 2 times 5x will give me 10x. 5 times 2x will give me 10x. The other option, that's also fairly simple, is to multiply the first equation by 3 and the second equation by 4. What will happen there is we'll end up with 12y in both equations. 3 times 4y is 12y. 4 times 3y is also 12y. Either way, we're going to have either 10x that we can subtract or 12y that we can subtract. You can use other numbers to multiply your equations as well, but the simplest way is to try to make them something in common and something small. You could pick something crazy like, maybe I want to multiply the first equation by 12, and then I want to figure out what I need to multiply the second one by to get one of these that I can eliminate. Then you're working with really big numbers, and that gets pretty complicated pretty quickly. The easiest way to think about this, in my mind anyway, is to look at these two numbers, or these two numbers, pick one set I should say, and then multiply by the opposite. So we have a 4y here, I'm going to multiply the second equation by 4. We have a 3y here, I'll multiply the first equation by 3. Or 5x here, multiply the second equation by 5. 2x here, multiply the second equation by 2. No matter what you do, as long as you do the math correctly after multiplying and eliminating and substituting, you'll end up with the same answer no matter what you do here. So since I have a 3 and a 4 here, I'm going to leave it like that. And I'm going to use these equations. So I'm going to multiply the first equation, all the terms, by 3. So 5x times 3 will be 15x. 4y times 3 will be plus 12y. And 38 times 3, let me think about that, 114, I believe. Next equation, 2x times 4 will be 8x. 3y times 4 will be 12y, which is good. That's what we have in the top. And 25 times 4 is 100. Now, since I have positive 12y and positive 12y, to eliminate them, I'm going to need to subtract the second equation. So the way I usually write it is subtract and then put the entire thing in brackets, so I know I'm subtracting the entire thing, not just the first term. If you don't have the brackets here, it looks like a negative 8x, and that's a totally different question. You can also do like what Sal or Saul or whatever his name in Khan Academy did, and change all the terms so they're negative. So you're basically multiplying by negative 1. So you'd have negative 8x, negative 12y, negative 100, and then you'd add them up. Either way works. You're doing the same thing, just in a different order. So I have my negative, I have my brackets, I'm ready to go. So 15x minus 8x will give me 7x. 12y minus 12y is 0y. So that's nothing. 114 minus 100 is 14. Divide both sides by 7, and I'll end up finding out that x is equal to 2. Again, I can pick any of these 4 equations and substitute x equals 2. I'm going to pick this one because it has kind of smaller numbers, and that's easier to work with. So 2 times x, which is 2, plus 3y is equal to 25. So that's 4 plus 3y equals 25. Subtract 4 from both sides. I'll have 3y is equal to 21. Divide both sides by 3, and y is equal to 7. So my ordered pair is 2, 7. This is my solution to this system of linear equations.